So this is an instructional video on my typical example for explaining powered triangle. It's a little bit advanced in that we will typically start with watts and vars and VA, but this is kind of a basic introduction when we get to a series circuit and how we use the powered triangle. What we're going to do is calculate the current in this circuit first. We're going to calculate I, and then we're going to calculate total power, and we're going to calculate total VARs as well as total VA. Being a series circuit, the total current IS, which I added the S to, also please make a note that I added the voltage here 20 angle 10 degrees. And so the total current flowing through this series circuit is E divided by ZT. And so it's 20 angle 10 degrees divided by 5.6 plus J 4.2 minus J 1.7, where the 5.6 plus J 4.2 minus J 1.7 is ZT as we're looking into this series circuit here. That gives us a result of But before I do that, I want to show this calculation in the Inspire. So I reduced the Inspire window here so you can see my keystrokes as I go along. So I like to use a lot of parentheses when I'm doing this. So I'm going to start with a parenthesis and then to type in 20. For those that aren't real comfortable yet with your Inspires. To get the angle, I hit Control, and then the alpha beta blue letters here above the open book takes me to this screen where I can select my angle. And now I'll type in 10 and end my parenthesis. Now divided by, and you've heard me say it time and time again in class, when to use polar numbers and when to use rectangular numbers. And this also gives you a good example of when I use polar and rectangular. I like to use polar for voltages and currents, and so you can see my voltage here is 20 angle 10 is in polar form, but I leave my impedance in rectangular form because I like to have my impedances in rectangular form. Now I can type in my 5.6 plus J. J is here under the pi button. Select I. Minus J. 1.7. And of course pay attention to your fellow classmates because a lot of times they will know shortcuts that I don't know. And so we try to talk about this in class, but we don't always get all of them. Now I can hit enter. And that gives me an answer of 3.26 at an angle of negative 4.14. 3.26 at an angle of negative 14.1 degrees. Another thing I like to go over is when you think you made a mistake, you need to be able to go back. So if I hit my arrow up button, I can go back and select what I put in. Now if I hit enter, now I can go in and edit that if I know I made a mistake. And you can see you use the arrows there to do that. Okay, where it's red up here, above here. So it's a very handy thing to use. Okay. So I would write my answer over here. I would put and over here on the right hand side, I'm going to put IS equal to 3.26 at an angle of negative 14.1 degrees. Amps. Don't forget your units. And I'm going to put a box around it. Now that I've calculated the current, the only thing that consumes power in this circuit is the resistor, the 5.6 ohm resistor. So my total power in this circuit is going to be, I can use I squared R. Now when I do this, this is just magnitudes only. So if I was going to write this a little more correct mathematically, I'd do magnitude. Put the two magnitude bars on both sides of it. times R. And so this would give me 3.26 squared times 5.6. And my result turns out to be 59.5 watts. And again, I wrote it over here incorrectly the first time. Okay, now QT is a little bit different story because Q VARs are provided by both inductive reactants and capacitive reactants. Inductive VARs, we got to remember, are positive, and capacitive VARs are negative. So in C, let's go calculate the inductive VARs first. I'll usually put a little L there, and I'll say that Q sub L I squared X sub L. Magnitude only again, so 3.26 squared times 4.2. And for the capacitor, QC, again, this is going to be positive. Inductive VARs are going to be positive. Capacitive VARs are negative. BI squared X sub C, or 3.26 squared times 1.7. Notice there's no J's in either one of those reactive arguments. This is going to be negative. And those results turn out to be 44.6 VARs inductive, negative 18.07 VARs capacitive. And what happens then is we add those two together, given respect to the negative sign of the capacitive VARs, turns out to be 26.53 VARs for QT. And I always put this, try to remember to put this inductive, this L beside it to indicate that it's inductive as well as the positive. Now, in that case, those are kind of redundant, but either one can be used. The reason we call this power a triangle now is as we get to what's called the apparent power, which we use the letter S to represent, and ST for the total apparent power, we take, this is actually, would be total power in watts, plus or minus J, the total reactive power, or reactive VARs. So we take PT from above, this would be 59.5 watts, plus J, 26.53 in VARs. And again, the positive would indicate inductive VARs. And again, I'll put a square around that. I actually prefer to rewrite the ST again, plus J. And this is the total apparent power being provided by the source. We're going to look at one more way to calculate that. Now I'm going to calculate this one other way. And this is how I always remember the formula, that ST is equal to VI conjugate. And now we're looking at this from the source standpoint, where out here we have E and we have I. Now remember, V is always usually used as a response in a circuit, but it's interchangeable with E, which usually represents a source. So this also could be written as E I conjugate. And the conjugate means that we change the angle on the sign. So the total apparent power, ST, would be equal to 20 angle 10 times I, and our I was 3.26, and I'm going to conjugate the angle now. It was positive, it was negative 14.06. I'm going to make it positive 14.06. Again, it was negative 14.06 degrees. I'm going to make it positive. Now, I'll plug those into my percolator, but in this case, because they're polar numbers, I can actually do this in my head. So I just multiply the magnitudes, and then I add the angles. So 20 times 3.6 would be 60. Point 65.2. At an angle of 24.06 degrees. And those units are VA. And I see I made a mistake up here. This should be VA. These are not VARs, those are VA. And that's in polar form. And what happens is, if I change this to rectangular form, you'll see that I'll get the same answer as I got up here. Now, let me go ahead and go back to, and I'm going to enter those numbers in so you can see them. So I have 65.2 angle 24.06, 24.06 in parentheses. Sorry. Yes. Now I need to convert it. So I hit my menu button, go to number 2. I can punch in 2, then I can punch in 9, and then I want to convert to rectangular. And I hit enter. And that gives me the number 59.5 plus J 26.6 VA. And this is watts. I guess this was okay. This should be watts and VARs. S is in VA, P is in watts, and Q is in VARs. And that completes this video.